Now, after understanding the first part of the electrochemistry chapter, which is basically the Daniell cells, let us move to the second type of cells, which are called electrolytic cells. So basically in this we will be dealing with the electrolytic cells. Now, before moving into the topics like conductance, we must first understand certain terms which are specifically used in these type of cells, or in particular in these topics. Now, the first thing you must understand exactly is what basically these electrolytic cells are. See, electrolytic cells are, as a large, basically is a vessel which is actually is almost as like this. In this, what we do is, this is called electrolytic vessel. In this, what is done is, a medium is taken for conducting electricity between the two electrodes, and the medium taken is called the electrolyte. The medium taken is called electrolyte. Now, this electrolyte is most important to us because it can be a molten substance. It can be basically in three states: in molten, infused, or in aqueous. In molten, we take the substance and we just melt it by heating it. So it's the pure substance which is present there. In fused state, what we do is we mixes two different substances and then we heat them so that they get melted, and we have that the mixture of those two substances or more than two substances in the liquid state. Now, the benefit is that once we add another substance to the one which is actually to be electrolyzed, the melting point gets lowered, the conductance of the charge gets increased. So these are the few benefits we have in the fused state. We can also have the substance dissolved in water in the liquid state, and that is what we call an aqueous state. So electrolyte can be any one of these three. Then we use metal rods which are called electrodes, and we know these electrodes can be your anode or they can be your cathode. Anode will be the electrode where oxidation takes place, and the cathode will be the electrode where reduction will take place. But the fundamental, the basic thing, please again, don't remember cathode and anode from the charges. You have to remember from the definitions. Now, what we do is, we connect these electrodes to an external source of electricity, which is usually your galvanic cell. Now, the small terminal of this is the negative terminal, negative pole, which is basically the anode of your electrochemical cell. And from here, what is coming out are the electrons coming out. And that is why the electrode which is connected to the negative terminal of the cell is called cathode. This will be your cathode, the reason being, and it will be given a negative sign because it is connected to the negative terminal. And since electrons are coming out of it, reduction takes place at this end. That is why it is called cathode, and since it is connected to the negative terminal of the cell, it's given a negative sign. Whereas the other electrode which is connected towards from the positive terminal of the cell is called your anode, because oxidation will take place at this end and the electrons will move from this end to the cell. So this is what is anode, which is connected to the positive terminal of the cell. So this is basically the general terminology which are used in electrolytic cell. The electrode which is connected to the positive terminal of the cell is called anode, and is given a positive sign because it is connected to the positive terminal of the cell, and it is called anode because oxidation takes place, and that is why this electrode becomes rich in electron, and these electrons move towards the positive terminal of the cell. So this is how we can, these are the general terms which are used in your electrolytic cells. Now, most important thing in this electrolytic cell is this, that we are using this electrolyte as the medium of conducting electricity. See, you have studied in the physics that the normal metals which we use in the form of the wires are called metallic conductors. and you have done all the basic laws which governs the conductance of the charge through those metals. In a very similar way, we must understand here that now here we are using this liquid state substance which is called electrolyte as the conductor, and that is why the conduction of the charge through these electrolyte is called electrolytic conductance. Now we must understand the behavior of this electrolytic conductance, how conductance takes place through this, and what all are the factors on this. The conductance of depends on this particular type of conductance. Like what all are the factors on which the passing of the charge, the conductance depends on this, and then we will move into the formulas of this. So now let us first understand the factor which affects the electrolytic conductance, which means what all are the factors on which the conductance of the charge is depending on when it is passed through these electrolytes. Now before moving into the factors which affects the electrolytic conductance, let us very clearly understand that how this type of conductance is different from a normal metallic conductance, which is actually the conductance of the charge through a metal wire. Now remember, in this electrolytic conductance, the charge carriers are the ions and not the electrons which are there in your usual metallic conductors or in metallic conductance. Another important thing, that the decomposition of the electrolyte takes place in this type of conductance, because those ions which on reaching their respective electrodes, they get decomposed, they get reduced or oxidized, whereas no such thing happens in case of metallic conductance. Another important thing, it increases with increase in temperature, because kinetic energy of the ions gets increased, whereas in case of metallic conductance we know the conductance decreases with the increase in the temperature because the resistance gets increased. So these are the few factors on which we can say that this is how the electrolytic conductance is different from the normal usual metallic conductance. But yes, we must understand what all are the factors which affects this electrolytic conductance. The first term to understand the electrolytic conductance is called the conductance. The symbol of this term is G, and it is defined as the reciprocal of the resistance of the electrolyte, or resistance offered by the electrolyte to the ions. So conductance is the reciprocal of the resistance, and it basically deals with the resistance which is offered to the ions in electrolytic conductance. And we can easily make out that the electrolyte which will be offering more of the resistance will have less of the conductance, and which will have less of the resistance will have more of the electrolytic conductance. So this is the reciprocal of the resistance. Its unit is therefore is called Ohm's inverse, because it's the reciprocal of this one. And this resistance we can measure by using the electrodes, maintaining a certain distance between them, fixed distance, and we are passing the electricity, we can measure the resistance. Now, but in order to compare the conductance of the different electrolytes, we need another term which is called specific conductance, or the IUPAC as suggests it should be called conductivity, whose the symbol is kappa, which is K written in italics. Now it is basically is the reciprocal of the resistivity. Now from the physics we know the resistivity is resistance into A upon L, where A is the cross section area If we keep in our mind the metallic conductors, this A is the cross section area of the wire and L is the unit length of the wire. So this is how we actually use as resistivity or specific resistance. See, the main purpose of using specific resistance is that it becomes a comparative property. We can compare then the resistance between the different substances by taking their unit cross section wires of unit cross section length, and then we can compare the resistance, and the one which is offering the less resistance is a better conductor. In a very similar way, we will be using this term in the electrolytic conductance, like in the form, like if we places the value here, the kappa comes out to be 1 by R into L by A, and this can be written as 1 by R, we know is our conductance, so it becomes L by A, and in this L by A is called cell constant. So what we can write as the conductivity is that the conductivity is equal to the product of conductance into cell constant. Conductance into cell constant. Now here this cell constant is basically the surface area of the electrodes used and the distance between the electrodes. Now in order to compare, like if we want to compare that out of like KCl and NaCl solution, which is a better electrolyte, we must take the electrodes of the same cross section areas or the same surface areas, and the distance between the electrodes to be used in both of these electrolytes should be the same. So we developed therefore conductivity cells. Now these conductivity cells are almost like this cylindrical in shape. They have a hollow end at the end here. A hollow cap is attached to here, which is having two platinum electrodes of surface area 1 centimeter square, and the distance between these electrodes is 1 centimeter. And once these conductivity cells are dipped into this, the solution gets filled in between these two platinum electrodes, and we measure whatever the ions which are present in that solution electrolyte which is present between these two platinum electrodes conduct electricity, and whatever the conductance they show, since the cell constant is 1, becomes the specific conductance, and it can be used to compare which is a better electrolyte. So this conductivity cell is used. The cell constant usually is written on these conductivity cells, or we can determine them by using the standard KCl solution, and then we can find out the conductivities of the different electrolytes and we can compare them. What will be the unit of this conductivity cell? Now let us see the unit of the conductivity. This conductivity will be ohms inverse centimeter inverse, because centimeter upon centimeter square will make it centimeter inverse. So the unit of this will be ohms inverse centimeter inverse, and then since the electrolyte which comes in between these two platinum electrodes of surface area 1 centimeter square and having a distance of 1 centimeter between them will be 1 cubic centimeter or 1 ml. We define kappa as the conductance shown by all the ions present in 1 cubic centimeter volume of the electrolyte. So whatever the number of ions which comes in 1 ml of the electrolyte, whatever the conductance they show is called the specific conductance of that particular electrolyte.